Hello students. You know, during this time I can't be with you personally, so my daughters and I figured we'd make you a video. And today we're talking about density. So here I have my young upcoming 6th grader Annie, and behind the camera is JoJo, and I want to thank them for helping me today. So first of all, we need to know a few pieces of equipment in order to measure density. So here, you guys might not know what this is, okay? This is an old 35 millimeter film canister, and we're going to use this as a demonstration today about different densities. These are all 4 of the same canister. This, Miss Andy, you remember what this was called?
Cylinder.
Yes, it is a graduated cylinder. So it's a cylinder that has numbers that help you measure liquids. This is a graduated cylinder, and we're going to use this today to measure volume. And we're going to use the method of displacement. Just like when you get in the bathtub, and I know Annie likes baths. When you get in the bathtub, what happens to the water? Well, when you get in the bathtub, does the water change?
Well,
What's it do?
flow?
It goes up, right?
Yeah.
That's right, because your body is displacing the water, which makes it go up. So today we're going to use a graduated cylinder, and we're going to put our film canister into the graduated cylinder, which is going to displace the water and raise the level. So Annie, my assistant, what is the level currently?
150.
150 milliliters. And always, students, when you're measuring in a graduated cylinder, it's going to curve a little bit up on the edges. You look at the bottom of the curve. This is called the meniscus. This is the proper way to measure in a graduated cylinder. So Annie, what I'm going to ask you to do is tilt the graduated cylinder and then slowly slide the film canister in. Now while she's doing that, I want to tell you why it's important to tilt the graduated cylinder. Because you don't want any water plopping out, because that water is very important for your demonstration, okay, or your measurement, okay? Yep, tip it and then slide it slow. Good. Excellent job, Annie. Now, Annie, now where are we at? And I'm going to write this down. 192 milliliters. So 192 milliliters, and we started at 150 milliliters. So this is our problem. The water rose 42 milliliters. So Annie, what would the volume of that film canister be?
42.
Exactly right. Are you a daughter of a science teacher? She is. 42 milliliters. So volume is a measure of how much space something takes up. So we got our volume by measuring displacement, and we have 42 milliliters. That's going to be an important number, and we're going to remember that. So remember, 42 milliliters. Okay. Now, let's look at what happens, okay, with different densities. Annie, can you please place the film canister in the first beaker? What's it do? It floats. Can you please place the second canister? Did you guys hear that? Boom. It sinks. How about the third canister? It kind of suspends. That's really weird. It doesn't float, but it doesn't sink either. It's kind of in the middle. Let's put our thinking caps. Did you notice anything different about the film canisters? Because they all had the same volume. They all took up the same amount of space. So what was different, Annie?
One was lighter and one was heavier.
One was lighter and one was heavier. So you talking about the mass of the film canisters?
Yeah.
Yes, the mass was different. Oh, Mr. McClelland, I put some different objects into the film canisters to change its mass. Now, volume is the measure of how much space an object takes up. Mass is a measure of how much stuff there is, which is different than weight. your mass is the same here on Earth as it is on the moon. If you weigh 120 pounds on Earth, okay, you only weigh 1/6 of that on the moon. Well, 120 divided by 6 is 20, about 20 pounds. Wow, what a way to lose weight. Just take a ride to the moon. Now, but you don't lose mass. Astronauts leave Earth hopefully with 10 fingers and 10 toes. And when they come back from Earth and they parachute down and land in the ocean, guess what? They have 10 fingers and 10 toes. Their mass has not changed. Their weight has changed, but their mass. Because weight is the effect of gravity on a mass. So now we have to figure out something. So let's take some measurements. Okay, so this is the suspension. This is the sinker. And this is the floater. Okay, Annie, come on over to the triple beam balance. This is called a triple beam balance. And a triple beam balance, and you see it here, has 3 beams. That's why it's called a triple beam balance. Okay, now we're not talking about a Phillies hit triple like what's his name? Gosselin. Yeah, Gosselin loves hitting triples. Okay, so we'll take the first canister that floats, and we're going to put it on there, and then please move the ones until you think you got it. A little more, maybe about 5. A little more, 5.5 maybe. Oh. There you go. About, if you read it here, it's about 5.7 grams. So an empty film canister weighs 5.7 grams. Now the sinker. Oh, let's put these down. We're gonna have to go by 10s. So move the 10s until it goes down. Keep going, keep going, keep going, keep going. Oh boy. Oh, less than 100. Let's see, less than 90. Nope. Yeah, less than 90. Okay, 80. Then move this one. In case you're wondering, the triple beam balance, okay? This front beam, the increments are in 1/10 of a gram up to 10 grams. The increments on the middle beam are by hundreds of grams up to 500 grams. And on the third beam, they're increments of 10 up to 100 grams. And what you do is you manipulate these until you figure out how many grams the object weighs. We're talking a little more, a little more, a little more, a little more. Oh, stop. Go back. Okay. A little more, just one more. There we go. So we're talking 80 plus 9.5. So 89.5 grams. Okay, so the one that sinks is 89.5 grams. Now, let's measure this one. $40. A little less, a little less. There we go. Just about 42 grams. 42 grams? 42 grams? Oh my, 42 grams? That's an important number. Let's look. Do you remember what our volume was?
42.
42 milliliters, which was the volume of the film canister. That's volume. Okay? And what is the mass?
42.
42 grams. So what is 42 divided by 42? 1. 1, and we couldn't do anything with the units, so it's 1 gram over milliliter. And this, by the way, this was mass. So 1 gram over milliliter. Guess what the density of water is?
42.
No.
1 gram.
1 gram per milliliter. 1 gram per milliliter. This is the density of water. This is why this third one kind of didn't sink and didn't float, kind of suspended. So now this is going to bring us to the formula for density. And by the way, first question on your density quiz is going to be, please write the formula for density. So students, make sure you have this. So please hold my pen, and I will do through the magic of whiteboard. Okay, so what number do we have on top? We had grams, which is what? That's the, was it the mass? Yeah, it's the mass. So mass, right, divided by volume. Very good. Volume equals density. Okay, mass over volume equals density. Remember, when you're doing your calculations for density, we had 42 grams, and I divided it by 42 milliliters, and it equaled 1 gram over milliliter. Always remember your units, students. Your units are very, very important in science. Okay, one more time. I want to show them a little trick. This is a McClelland trick that I learned a long, long time ago, back in high school. Mr. McClelland, I gave my heart to a girl. And you know what she did with it? She broke it. But I took that and said, I can use that to remember density on my density quiz. What do you have up on top? What letter? M. And on the bottom? V. So mass over volume equals density. So it was not destiny, but it was density. She taught me a valuable lesson. So what you do is, if you forget the density formula, take a heart, split it in half. M over V, mass over volume. That's density. So I hope you learned a little bit today about density and a little bit about the equipment that we use to measure density. First of all, to measure volume, we use a graduated cylinder. It's a cylinder that has markings for measurement. For mass, we use the triple beam balance. Okay? Now, remember, your mass does not change. It doesn't matter where you go in the universe. The amount of stuff that makes you up is always the same. Your weight may change, like if you go to the moon or Mars or Jupiter. I feel really heavy on Jupiter because of gravity. Because weight is the effect of gravity on a mass. And we learned that if the object, mass over volume, is less than 1, which it was, it will float. If it's more than 1, it will sink. And if it's kind of right at 1, it'll kind of suspend in the middle. Thank you for watching our video, and thank you, Ann, for being my assistant up top. And thank you, JoJo, for being our cinematographer today, and that is Dan.